In this segment on algebra, we're going to be talking about collecting like terms. And so the question is, what's a term? How is it like? And how do you collect them? In mathematical terms, we often call it a term is something that has the same variables to the same powers, which is a nice fancy way of what I say is it's something that has the same shapes. And they can be separated by adding and subtracting signs, because when I multiply, I can create a new shape, and we'll talk about that in just a second. So if my question is 2 plus 3, the shapes that I'm talking about are these ones. That's a positive 1, and that's a positive 1, so now there's positive 2, and to that I'm going to add positive 3. 1, 2, 3. And so I can combine these together and get a total of 5, but my shapes haven't changed. I still have 5 little tiny unit squares there, and so I can add these together. I can combine these terms, if I will. That's one shape, that's another shape, or a series of shapes, and therefore I haven't changed anything. I haven't changed the shape, and I can collect those to get a total of 5 of these same shapes. When I go to multiply 2 times 3, I could say I have 2 sets of 3. So there's 1, 2, and then 3, and then I have another same set of those, 2 sets of 3. And you could argue possibly that now I've got a new shape, I've got a new rectangle here that's 2 by 3, which is a total of 6, but it's still made up of the same shapes. And I haven't really changed anything, because I can just rearrange those in a different pattern and have them down this way. 2 sets of 3, so there's one set of 3 there, and here's another set of 3 over here, so I still have my 6. So I haven't really changed anything when I'm talking about my straight numbers, my constant units. When I'm talking about x's though, if I had 2 x's and I add it to another 3 x's, I would have a total of 5 x's. And so I haven't changed anything there. So I have my terms, my x's, my shapes, and I have 2 of them plus 3 of them, and so therefore my question might look something like this, and that would give me a total of 5 x's. However, if I wanted to multiply x's, I get something very different. When I go to multiply an x, I take an x and I multiply it by an x, and I do what we did with the 2 times 3 and I make it into an array, I get a completely different shape now. So when we talked about separating the terms, and we say they're separated by adding or subtracting, adding and subtracting doesn't really change our shape. But when I multiply variables, their shapes change. If I was to take an x shape and multiply it by a y shape, I'm going to get a completely different shape than either of those two that I start with. And I would get something called an xy shape. It has a height of x and a width of y, so its area would be xy. So that's a completely different shape. So this is why if I added x and a y, I added an x and I added a y, I would have 1x plus 1y, and they would be separated by an adding sign. So 1x plus 1y, I would have 2 separate terms because I have 2 separate shapes. But when I multiply x times y, as I did here, x times y, and I notice I don't put an x in there because that confuses the x, that is the letter of the shape, times the x of the symbol for multiplication. No symbol in between means multiplication. So xy isn't 2 terms. X times y gives me a new shape, so this is called my xy shape. And notice that there's nothing between the 2 terms here, and there's nothing between the 2 terms here. So when I multiply 2 things together, I get a whole new shape. So terms are things that have unique shapes to the one. And this is why it's very useful to take a look at the concrete manipulatives to help students understand the idea behind terms and shapes and which things you can collect. So if I'm given this algebraic expression, now it's called an expression, not an equation, because there's no equal sign. I only have one side. If I have an equal sign, then there's a left side and a right side. So this is called an algebraic expression, and I want to simplify it or collect like terms. Another way of thinking about it is let's collect all the shapes. So I'll draw it out first of all in shapes. So here's my question drawn out in shapes. I have a 3, 1, 2, 3. I have an x, there's my x. I have a 2, 1, 2. And I have 3 of the x shapes, 1, 2, 3. And if I say collect like terms, well, I can put all my number shapes together, and I can put all my x shapes together. So altogether I would have 1, 2, 3, 4, 5, and I would have 1, 2, 3, 4 of these x's. So I would write it this way, and it would look like 5 plus 5x. Now, mathematically, 5 plus 5x and 5x plus 5 mean the exact same thing. But like in English, there are certain kinds of agreed upon grammatical ideas that we use so that we're all following the same kind of pattern. And in mathematics, we talk about putting our numbers and letters in order from the highest exponent on the left all the way down to the lowest exponents on the right. So the proper way of writing this would be 5x plus 5. And it would still show that I have 4x's, 1, 2, 3, 4x's, and 1, 2, 3, 4, 5. So it should be 4x plus 5. I'm sorry. There it is, 4x plus 5. So I could say 5 plus 4x or 4x plus 5, but grammatically it should be done 4x plus 5. Let's try a different question. So here's my question. 2 plus x squared plus x plus 3x plus 2x squared plus 2. So let's change those into my pictures so I can see which things I want to collect. And there's my pictures there. I've got 2, I've got 1x squared, I've got 1x, I've got 3x's, I've got 2 of the x squareds, and I've got the 2's. Now the instruction could say simplify or collect like terms. So I put all the shapes together, and we're going to put them from the highest ones, the highest exponents first, and the lowest ones last. So we'll put those in order, and we'll get the following. So I've collected them all together, and I can easily see that I have 3x squareds, 4x's, and a 4. Taking a look over here, I can see that I have a positive 2x squared and a positive x squared. I like to think of it as collecting the sign out in front, because lots of students get confused. We're going to do one in a minute with the negative signs and the positive signs. Is that an adding or subtracting? I like to combine the two together so I know if it's a positive shape or a negative shape. So there's my x squareds and 2x squareds, giving my total of 3. Here is a 1x, a positive x, and another positive 3x. So that gives me my positive 4x's, and here's my positive 2 and another positive 2 giving me positive 4. I'm going to try another question. xy plus 2x plus x squared plus 3x plus xy. Let's change those into my pictures before I can collect like terms. And there it is converted over into pictures. I have an xy term, which is this. It's x high by y across. This is x. I have 2 of them. This is my x squareds. I have 1 of them. I have 3 of my x's, and I have another one of these xy's. Collecting like terms, well, I have my x squared, so I'm just going to move them in order, and I would get my answer of, I have 1x squared, I have 2 xy's, and I've got 1, 2, 3, 4, 5 x's. And it would be written like that. And our last question here, 3 minus x plus 4x squared minus x squared plus 3x minus 4. Now this one's a little bit more complicated because we have some negatives here now. And so I'm going to draw my diagram first and see if that helps our explanation. And so here's our pictures. We've got positive 3x's, so 1, 2, 3 x's. Now, some students say, okay, what do I do with this minus x? Do I take away a green x? But if I take away a green x, what do I show? So I like to think of it as, okay, this is a minus x, and so therefore I have my negative x. Here I have my positive 4x squared, so 1, 2, 3, 4x squareds, and here I have the same problem again. I have this minus sign. This minus sign could also be a negative x squared. So this piece right here, this negative x squared, is going to give me my red x squared. Positive 3x's, 1, 2, 3, and again I have the same issue here. Is it subtract 4 greens, or is it the same thing as negative 4, which is 4 reds? So there's my 4 reds. Now when I go to collect like terms, I have to collect things that are the same. So I'm going to put my x's together, my numbers together, my x's together, and my x squareds together. I'll do that right now. So there's my pictures, and I have positives and negatives. So I've got 4 positives and 1 negative. So I can go 4 subtract 1, which gives me 3. But I could also think of it just like our work with our integers. That is a positive and a negative. So that's a 0 pair. So that can go away. Here I have a positive and negative, so that's a zero pair, so that can go away. And here I have a series of zero pairs, 1, 2, 3. So they can go away. So what do I have left? So what I have left is 3x squareds, 2x's, and a negative 1. And so we can call that a minus 1 if we like, but it's a negative 1 left over. So again, we're looking at, when we're collecting like terms, it's so much easier to understand what a like term is when you put it into shapes. And showing the shapes, seeing which zero pairs we have, we can collect like terms, and we can get our answers using that. So I have a positive 3 and a negative 4. Gives me my negative 1. I've got a negative x and a positive 3x. That gives me my positive 2x. And a positive 4x squared and a negative 1x squared gives me my 3x squareds. So there they are in the symbolic. Here it is in the concrete. I think it's really important to show the concrete pieces so that they can see how to connect like terms.